Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is a review video for my MCF 3M students who are working on exponent laws. First of all, let's go through some exponent basics, things we know but need to make sure that we know really well. This is the fundamental of an exponential expression, a base of x, an exponent 4, and we know that that means that what we really have is x times x times x times x, so the base multiplied 4 times. Now, what's just as important as understanding that basics is looking at these two expressions and knowing that these are saying different things. Here, the base is x with exponent 4. And then it's multiplied by 2. So again, here the base is x, and that has exponent 4, and that's then multiplied by 2. Whereas here, the base is 2x. So both the 2 and the x have exponent 4. So it's really important that you see the difference between 2x exponent 4 and bracket 2x exponent 4. Okay, so also just some, again, fundamentals. Clearly there's a difference between these two. Here the base of y has exponent 2, whereas the base of x has exponent 1. And that's an important basic to remember, that if you see a base or a variable, it has an exponent, it's exponent 1. Whereas here, I have x1, y1, but both of them are the base, so they both have exponent 2. So again, make sure you know what the base is that has the exponents. And again, obviously, same idea here. Base x has exponent 2, base y has exponent 1. Here, both x and y have exponent 2, which is why they're both in the bracket. So, let's look at the exponent laws. So we know that if I have x squared and y 5, there's nothing I can do with that. They're different bases, and if I were to expand it, I would have x times x, and then y times y times y times y times y, and there's nothing I can do to write it any simpler than how it began, which is x squared and y 5. Whereas here, if I have x squared times x5, if I expand it, I have x times x times x times x times x times x. So I have x squared times x5, and now there is a further simplification because what I have are 7 x's multiplied together, which is x to the 7. And so the exponent law there that we know is that if the bases are multiplied together, you add the exponents. So 2 plus 5 is there's 7 x's. And so that's what the exponent law looks like. Feel free to pause here if you need it. Now there's another exponent law, which is for what happens if we divide the bases. And just like when we were talking about the product law, x to the 8 divided by y cubed, well, those are different bases. So there's no exponent law here. There's nothing I can do. Whereas if I have x to the 8 divided by x cubed, because those are the same bases, an exponent law will happen. So just a quick reminder that the exponent law happens because the top of that fraction is x times x times x times x. I have 8 x's multiplied together, and the bottom is 3 x's. So if we now do our simplification, this x can cancel this x. This one, and this x cancels this x. So I'm left with 5 x's and nothing on the bottom. And so that reminds us that this is actually x5, which should remind you that the exponent law is if you divide the same base, you just subtract the exponent. So 8 minus 3 is a shortcut to know that the exponent should be 5. Okay, so there's the quotient law that we just talked about in formal form. And then the next exponent law is the one that says if you have a base that has an exponent, so here's x, and it has an exponent, and then there's a higher exponent, meaning like above that one or beyond that one. So this exponent kind of has its own exponent. And that exponent law tells me we're going to multiply them together. And the reason is because, simply that we know that x cubed squared is x cubed times x cubed. And x cubed times x squared, x cubed, well, if we now use the product rule, multiply the bases, so add the exponents, that's x6. And of course the shortcut is multiply this exponent times this exponent. And don't forget that with this particular exponent law, everything that's in the bracket has that exponent. So here, what I really have is x to the, I have x to the 6, 3 times 2 is 6, and y to the 10, because 5 times 2 is 10. So I have 2 times 3. I've actually got 6 of these. 5 times 2, I've actually got 10 of those. And if we continue, looking at this new law, here I have the same situation, except for I have that z. So please don't forget that z has an exponent. It's exponent 1. We just don't need to write it, but you need to know that it's there. So if I were to now use the exponent laws, I have x cubed with a higher exponent of 3. Well, 3 times 2 is 6. I have y5 with a higher exponent. 5 times 2 is 10. And I have z1. 1 times 2 is 2. So that would be my answer to that question. And again, same thing here, but for some reason, I don't know why, students like to mess this up. I know you don't like to mess it up, but you unfortunately do sometimes. Not all of you, please don't. And don't forget, so we need to remember that there is z to the 1. There's an exponent on z, and it's 1. But this number 4 is a base. It's not an exponent, right? I mean, you can see that clearly. It's just 4. So when I think about the fact that this squared happens to everything in the bracket, that means I have 4 squared. And then I have x cubed squared. Well, 3 times 2 is 6. I have y5 squared. 5 times 2 is 10. And I have z1 squared, which is z2. So you'll notice, if I write it like this, you can see that every single thing now has that exponent 2. 3 times 2, 5 times 2, and so on. And then I can say, well, I know what 4 squared is. 4 squared is 16. And then everything else is just exactly what you see. So please don't forget that if there's a coefficient in the bracket, it's a number. It's not an exponent. So here's what that law looks like that we just looked at, the power law, that says if you have an exponent that has a higher exponent, I keep doing something weird, then you multiply those two together. So a bit of practice now, and I do suggest that you actually get out your pencil and paper and really try to actually do this math before I show you my answer. It's a good way to study. This is where you should pause the video and try this question on your own, and welcome back. So let's go ahead and take up this question. So we have a big fraction. Now at the top of the fraction, I have a bracket times a bracket. And you'll notice that neither of those brackets have a big exponent. So the top of the fraction is just multiply the brackets together. The bottom of the fraction is a bracket squared. So I'm just going to square that. Okay, so let's do the top. 6 times negative 4. So again, the 6 and the negative 4, those are not bases or exponents. They're just numbers. 6 times negative 4. Well, that's negative 24. Then I'm going to do x squared times x5. So this is where the exponent law says, hey, if you're multiplying x times x, just add the exponents. 2 plus 5 is 7. And then I have y. So I have y to the 4 and y to the 1. So y4 plus 1. So I actually have y to the 5. So that's the entire numerator done and taken care of. And now let's do what's on the bottom of the fraction. So 3x1 y squared, all of those are now squared. So 3 squared is 9. x1 squared, 1 times 2 is 2. And y2 squared, well, 2 times 2 is 4. So now I've done everything I can in the numerator and everything I can in the denominator. So now I'm going to deal with the fraction line, which says to divide. So the fraction is negative 24 over 9. So I'm just going to go over here for a second. Negative 24 over 9. If that reduced to a nice number like 6 or 7 or 3, I would just write it. But this actually would give me a decimal. So therefore, I want to reduce this fraction as much as I can. You have a fraction button on your calculator. I encourage you to know how to use it. And if you don't know how to use it, then you just have to know that both of these numbers are divisible by 3. And if I divide negative 24 by 3, I get negative 8. And if I divide 9 by 3, I get 3. And then there's no other number that I can divide both 8 and 3 by. So that means when I look at just the numbers, negative 24 over 9, what I get is negative 8 over 3. Now I'll look at the x's. So I have x7 divided by x squared. So the exponent laws tell me that I can do 7 subtract 2, and I get x5. And then for the y's, I have y5 minus y4. Well, 5 minus 4 is 1, so I have y1, but I don't need to write the 1 because y means y to the 1. So that's my final answer. It's negative 8 x to the 5 y over 3, which, by the way, is exactly the same thing as if I wrote it like this. So I sort of create a fraction instead of a big fraction. So whichever way you write it is perfectly fine. So let's talk about the new exponent laws that you may have learned this year for the first time. Keeping in mind that all the exponent laws we've looked at for the first bit of this video are stuff that you learned earlier, in an earlier grade. So evaluate these fractions. 7 divided by 7 is 1. I don't need a calculator for that. 41 divided by 41 is 1. I don't need a calculator. Negative 185 over 1 negative, that's 1. We know that this rule in math exists, that anything divided by itself is 1. And so now I'm going to evaluate this. Well, I have a base of x, and when I have a base of x, and I'm dividing, I can subtract the exponents. So if I subtract 11 minus 11, I get 0. So I get this thing called x to the 0. But if I go back to what we were doing here, anything divided by itself equals 1. So, oops, I went the wrong way. So applying the exponent laws, I get that this is x to the exponent 0. But applying the fundamentals of math, I get that this is 1. And so that means that x to the 0 must equal 1. So anytime you have any base to the exponent 0, the entire package evaluates to 1. So that means if I have 632x cubed, but that's in a bracket with exponent 0, all of this, the whole thing, is just 1. That's why we love exponent 0. It makes math simpler. And here's what it looks like as a rule. If a base has an exponent 0, entire expression is 1. And so now to look at the next exponent law, I want to have a look at this chart. I know that if I do x times x times x times x, that's x4. So what I want to do now is I want to divide by x. So if I divide by x, that's 1 fewer x. So if I have 1 fewer x, I have x times x times x, which is x cubed. And then I'm going to divide by x again. So now I have x times x, which is x squared. I'm going to divide by x again. I have x, which is x to the 1. So notice the pattern here in my exponents. Every time I divide by x, I'm losing 1x from my expression. That makes sense. Now, I'm going to now divide by x again. So what is x divided by x? Well, x divided by x is 1. And look at the pattern in my exponent. I lost another x. Now, that's the exponent law we had just talked about, but let's keep going. I'm going to divide by x again. What happens if I do 1 divided by x? Well, I have 1 over x. And if I continue to follow my exponent pattern, I lost another x, so I have x to the negative 1. And you should recognize this as one of the exponent laws we learned this year, that a negative exponent means that the base is on the wrong side of the expression. And so let's just keep going a little bit. What if I divide by x again? Well, I would now have 2 x's in the denominator, which can be written as 1 over x squared. And if I follow my exponent pattern, I now have negative 2 as my exponent. So again, we see this negative, the negative exponent tells me that it's actually 1 over whatever else I have. And if I do one more example, divide by x again, now I have 1 over xxx, also known as 1 over x cubed, and you can see that the exponent here is negative 3. So that gives us a brief explanation of this exponent law, which says that if the base has a negative exponent, it means that the base is on the wrong side of the fraction. So remember that a is the same thing as a over 1. So when I say it's on the wrong side of the fraction, it became 1 over a. So for example, if I have x to the negative 3 and I want instead a positive exponent, I would write that as 1 over x cubed, because that negative sign said, hey, everything is fine, but you're on the wrong side of the fraction. So I said, okay, x and 3 are fine. It was just that it was on the wrong side of the fraction. Same thing here. This exponent law tells me that the x and 4 are good. They're just on the wrong side of the fraction. So this is actually x to the 4 over 1, which is, of course, just x to the 4. So let's practice, because sometimes, even though, you know, it's not enough just to know the law, right? Oh, I memorized the exponent law, I'm ready. No. We have to make sure we understand what's happening. So for example, in this expression, what I would do is I would say, well, the a, because of this negative exponent, a squared is supposed to be on the bottom of the fraction, And because of this negative, b cubed is supposed to be on the top. So now I've written the expression where I don't have those negative exponents anymore. And we prefer in math to not have negative if we don't need them. So this would be my answer. Here, if I look at this expression, a squared is perfectly fine exactly where it is. B, however, has a negative exponent. So this b cubed is supposed to be down here. C doesn't have a negative exponent, so that c is where it belongs. So the only thing that was on the wrong side of the fraction in this question is where the b had the negative exponent. Everything else, the a squared, no problem. The c, perfect. But that b was on the wrong side of the fraction. And another thing is I want you to look really carefully at these two expressions and make sure you see clearly that they're different expressions. And they mean different things. Here, in this expression, the x has a negative exponent. So the x is on the wrong side of a fraction. But the 3 does not have this exponent. That is just 3. So this expression is 3 over x squared. Again, the 3 was perfectly fine. No negative exponent, no exponent at all. So it's still 3. But it's the x squared that was on the wrong side. Whereas in this expression, the bracket tells me that both the 3 and the x are part of the base that are on the wrong side. So I need to rewrite this as 1 over, and then I can say 3x squared. So the only difference is that this negative sign is now replaced because it's now where it's supposed to be. So, time for more practice. Get out your pen and paper and try these 3 questions. So again, pause the video, copy these questions, and try to do these by yourself. Welcome back. Let's take these up. Okay, so, and the instructions were to simplify and write your answer with positive exponents. Okay, so simplify means apply the rules and laws of math, and then of course we want it written with positive exponents. So now I notice that there's a bracket with the exponent 5. That means everything in this bracket has that exponent 5, and following Bedmus, this big exponent on a bracket is what I should deal with first. So I have 2, and that 2 has that exponent 5. Then I have base x with exponent -3. So that means following the exponent laws, I do -3 times 5, which is -15. So now what? Well, 2 to the 5, I can actually calculate that. Remember, 2 is a number and x is a variable, so I have a calculator for a reason. 2 to the 5 is 32. And then this x, well, it's -15, which means it's on the wrong side of the fraction. So I'm going to take the x and the exponent 15 and write it where it's supposed to go. So that is my final answer. It's simplified with a positive exponent. Okay, hopefully that's what you got. Let's look at the next one. So I'm supposed to square all of this stuff. There's a couple different orders you can go in, but I'm going to follow exactly the order in the last question. All of this, everything in this bracket gets exponent 2. So 3 squared, right? There's a 3, it's not an exponent, 3 squared. And I have a, now the exponent has to be multiplied by 2, so that's a to the -4. Then I have b to the 1 multiplied by 2, 1 times 2 is 2, over c, -4 multiplied by 2 is -8. So again, anything that's an exponent is multiplied by 2. But the 3 is not an exponent. It's a number, so that's 3 squared. So now I'm going to do whatever math I can. So 3 squared is 9. The a has a negative exponent. So that means the a is on the wrong side. So the a is supposed to be down here, a4. The b, I got no problems with that b. B squared, it's perfect. It's not a negative exponent. The c is a negative exponent, and that means the c is on the wrong side of the fraction. So instead of c to the -8, it should be c to the +8 on the top. And that's my final answer. So 9 b squared c8 over a4. That's what you should have. Next one. So this one's got a lot of steps to it, but again, just follow order of operations. In the numerator, I have a bracket squared and then times by another bracket. So obviously I have to do the exponent on the bracket first. I don't have anything to do in the bottom yet, so I'll just wait. So let's do the bracket squared. So again, 4 squared. That 4 is not an exponent, so I do 4 squared. And then a negative 2 times 2 is negative 4. B to the 1 times 2, 1 times 2 is 2. And then I have 3ab over here. And then I haven't changed anything else so far. And I'm going to keep going, and I'm going to not worry about my negative exponents until I've finished completely looking at what the numerator is doing. So any math I can do on the top of the fraction, I'm going to do it all the way. If there were math to do in the bottom, I would do the same thing. So 4 squared, 4 times 4 is 16. So 16 times 3 is what I have to do. 16 times 3 is 48. Then I have a, so I have a to the negative 4 times a to the 1. So the rule says I have to add those exponents. Negative 3 plus, I gave it away, negative 4 plus 1 is negative 3. And then I have b squared times b1, add those exponents, that's b3. So this is what I have so far. So now, now that I have completely resolved the numerator, completely resolved the denominator, I'm actually just going to keep going with my exponent laws. Now, 48 is not an exponent. 2 is not an exponent. 48 divided by 2 is 24. Then there's a couple different things you could do here. So I'm going to do it sort of my way. And my way is that this a is on the wrong side of the fraction. So that should be a cubed on the bottom. B cubed, yeah, that's exactly fine. That's perfect where it is. Then I'm going to come down here. I already did 48 divided by 2. Then I have a on the bottom, perfect. It's where it's supposed to be, positive exponent 1. Put that in. This b to the negative 3, well, that negative tells me that that b to the negative 3 is supposed to be on the top. So I'm going to move it to the top. And now I'm going to apply the exponent law that says just add the exponents. So I have 24, and then I have b cubed times b cubed, so 3 plus 3 is 6. And then I have a3 times a1, 3 plus 1 is 4. And that's my final answer. Now, it's perfectly fine if at this point here, you had applied the exponents laws and said, oops, not bad. If you'd applied the exponent law and said, okay, 48 divided by 2, and then a, negative 3, so a to the negative 3, subtract a to the 1. Well, I said that wrong. It's a to the negative 3 divided by a to the 1, so I need a to the negative 3 subtract 1. B to the 3 subtract negative 3. And that would have given me 24, a to the negative 4, and b to the 6. And then I would have said, oh, that a is negative in the exponent. So it should be 24, b6, a4. Same answer. But what I find is that it's very easy for me to make a mistake when I look here at negative 3 subtract 1, and then 3 subtract negative 3. This integer math is very easy to sort of mess up, which is why I did it this way first. You do whichever way you like better, that you're less likely to make mistakes on. And now we get to, okay, so that was all questions were about the new negative exponent law. And now we get to the final law, which is probably the yuckiest. So first I'm going to give you the law, and it's the law that says if the exponent is a fraction, it means that there are radicals involved. Now a radical is this symbol. You may know it as the square root symbol, but it could be a cubed root, or a 13th root, or a 4th root. So we just say the word radical sign because root generally means the square root. So that's just the difference. And again, if you see this, it means the square root. We don't have to put a little 2 here to mean square root. And I just want to quickly talk about where this law comes from. We know that somewhere between 0 and 1, there's in-between numbers, right? Think about the number line. Does anything exist between 0 and 1? Absolutely. A half exists. A third exists. 5/6 exists. There's a bunch of numbers, in fact, an infinite number of numbers that exist between 0 and 1. So there are exponents that could be fractions. And if there's exponents that could be fractions, then there's numbers between 1 and x. So, for example, the square root of x is between 1 and x. the cubed root of x is between 1 and x, and so on. So that's where the exponent law comes from. It comes from us acknowledging that because there's exponents possible between 0 and 1, then there's values possible between 1 and x, and those values represent the roots, square root, cube root, fourth root, and so on, of x itself. So now this one, again, very new, but I just want to make sure I run through this with you. So how would I write this in radical form? So again, make sure you know that radical form means I want this sign somewhere in it. So what I do is I like to separate this, this exponent into two pieces, so I can clearly see the two different types of exponent laws going on. So what I see is 3, obviously 3. I see 3 divided by 4. So I'm going to separate that into two pieces. There's the 3, my good old-fashioned happy exponent, and then this new thing, which is to divide by 4. So that's 1 over 4, and you know that 1 over 4 times 3, it's still 3 over 4, so I haven't changed anything. I've just sort of pulled that fraction apart, because now I can clearly apply my exponent law, which says that this is actually the fourth root of 16 cubed. So that's my answer to the first part of the question, which is write in radical form. Now, because of the angle I've got at, I'm just going to rewrite it just to make sure that you clearly see how to write it. That 4, meaning fourth root, kind of goes in that little pocket of the radical sign. And now I just need to evaluate that. So what is the fourth root of 16? If you don't know it, use your calculator. It's 2, and then 2 cubed is 8. And if you're not sure what's happening, the reason why it's 2 is because a fourth root is asking you what number multiplied by itself 4 times gives you 16. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. That's why the fourth root of 16 is 2, and then 2 cubed is 8. And then this is another one that says write in radical form, then evaluate. So if you want to pause the video here, go for it, try it on your own. So what I'm going to do here, first of all, is I'm going to separate this into 3 different pieces. I know, weird. But when I look at this exponent, I see 3 things. I see a -1 because of the negative sign. I see a 1 over 2 because it says divide by 2. And I see a cubed. So I'm just taking sort of the 3 possible things that are happening in the exponent, and I'm just going to separate them out so I can do each one in turn. So the negative sign tells me that this is upside down. It should be 32 over 16. And so I dealt with the negative sign. And now I'm going to deal with that exponent 1/2. So exponent 1/2 means that this is actually the square root of 32. Oh, where did I get 32 from? Hold on, let me fix that. It clearly says 25. I don't know what I was thinking of. I guess I was still thinking of the last question. My bad. Okay, so let me erase. Erase. Because, you know, it would have been really hard if I had to find the square root of 32. So my bad. That was 25, right? 16 over 25 is now 25 over 16. So 1 over 2 tells me that I need the square root of 25 over the square root of 16. Now, I wrote the little 2 in there, but it's absolutely not needed. That means the square root. And the square root of 25, we know, is 5. The square root of 16 is 4. And then finally, I just have to do this exponent 3 on the 5 and the 4. So it's 5 to the exponent 3 over 4 to the exponent 3. And in my calculator, I get 125 over 64. And that's my answer. Okay, next one, write in exponential form with positive exponents. So exponential forms means I don't want this radical sign anymore. I want it to be like x to the something. So what I know is that I have x to the 4, and then it's the cubed root, which means it must have been divided by 3. So that's my answer. Right? The 4 is still the 4, but the cubed root, or the third degree radical, becomes divided by 3 in the exponent. So try this one. Pause the video if you want. So I need to write this in exponential form with positive exponents. So I know it's going to be x. And what's happening to x? Well, first of all, you can see that it was 1 over something with x, which means that as an exponent, I can put the negative in to say x came from the bottom of the fraction and it's no longer there. And then I see that I have a 3, and then I have this root sign, and there's no number here, which means it must be the square root, so it's 3 over 2. Now, it does say with positive exponents, so I guess what I really need to do is write it like this. So that's with positive exponents. So they mean, all of these three things mean the same thing. This is fully exponent form, and this is with positive exponents. Ooh, more practice. Okay. So this would be a good place again to pause the video and try these questions. So press pause, try these, and welcome back. So let's do these. Write in radical form, then evaluate. Leave your answer in fraction form. So remember, radical form means write it like this. Leave your answer in fraction form just means don't give me decimals in my answer. Don't worry about that. But we need radical form. So again, I see that I have a negative sign. So if we break this down into the 3 different pieces, we have a negative exponent. We have 1 over 3 because of the divide by 3. And then the top exponent is just 2. So negative, divide by 3, and 2. So then just taking each one in turn, 1 over 27 because of the negative sign. So 27 becomes 1 over 27. And then it's 1/3 squared. And then I need to take the cubed root. Now, I'm going to write it, but hopefully you see that's pretty silly to bother, but whatever. Technically, we are also taking the cubed root of 1 and the cubed root of 27. Well, the cubed root of 1 is 1, and then the cubed root of 27 is 3, because 3 times 3 times 3 is 27. So I end up with 1 squared over 3 squared, which is just 1 over 9. Okay, so you'll notice most of the time you don't even bother when it's 1 over, because 1 to any exponent is 1, but I just thought I'd be complete. Okay, in the next one, write an exponential form with positive exponents. So right now we have radical form because you can see the radical sign. So how am I going to write this in exponential form? So I clearly have x. It's on the bottom of the fraction. I have a 4 up top, normal. And then I have the 5th root, and we divide by 5. So that's exponential form, but it's not with a positive exponent. So with a positive exponent, I would write this. I would then put it back on the bottom and say, okay, it's 1 over x to the 4 over 5. Okay, so that's the video, but I know that many of you wanted some extra review on the exponent laws. Please make sure that you're actually going to do more than just watch this video, that you're doing practice questions. Thanks for watching. Bye.